Dear students, today we'll start the unit 4, that is nothing but module 4 according to your CBCS syllabus. And this module contains different sections, that is designing an architecture, documenting a software architecture, and implementation and testing. Under designing and architecture, we'll be studying what are the different design strategies, that is attribute driven methods, the steps of ADD, and uses and audiences for architecture, documentation, notations, view and behavior, documentation and quality attributes, architecture and implementation, architecture and testing. These are the different aspects we will be studying in this module. And let us start with the first section, that is designing the architecture. Earlier also we have been discussed many times, that is what is the architecture. Architecture is a structure of structures. It contains different parts, and each part performs its specific task in order to fulfill intended functionality. And designing architecture, it is the most important part in the case of software architecture. That is designing architecture, that is it contains architecture in the life cycle. Means before designing an architecture, the first process is what are the problem and what are the different requirements to fulfill that problem. Or another important task is what are the different tasks to be implemented in the model in order to get appropriate functionality. And the architecture in the life cycle, it has a different dimensions, or you can call it as a different parts to create a life cycle here. The first one is a software concept, and second one is a preliminary requirement analysis, and third one is design of architecture and system core. And another section contains this is a developer version and a deliverer version, and elicit a customer feedback and incorporate customer feedback. And the next is deliver a final version. Means you can see that is a different two direction arrows here from top to bottom. Means each step can be repeated multiple times depending on the specification of the problem. The each step can be iterated, or it can be implemented multiple times. That is, it is called the iteration here. If this phase has some issues, then again go back to the first phase, that is a software concept, edit it. And if this preliminary requirement analysis has some issues, again get back to the same aspect and fix the issues, and design of architecture and core. Again this design and architecture and system core contains different phases here: developing a version, delivering a version, and after delivering, the most important task is to get the customer feedback, whether the customer is fully satisfied or not. If the customer has some issues, or as a customer requires some modification or alteration, or the customer want to change the entire product, then we can again get back to the, that is incorporate customer feedback, go back to the development version, and next we can deliver the final version. Let us discuss about what is this evolutionary delivery life cycle. Designing the architecture, that is architecture and life cycle, especially deals with the aspect called evolutionary delivery life cycle. Evolutionary means it is slowly it is progressing from one phase to another phase to deliver a life cycle. And you can say architecture is the foundation for software development. In this section we will be understanding life cycle of the architecture. Several life cycle model exist, but among which evolutionary delivery life cycle model it is present, and it is a more efficient one compared to other models. That is, the intention and goal of this model is to get user and customer feedbacks. The main motto of this evolutionary life cycle model, that is, you can call it as architecture model. The main intention is to get the customer or user feedback, so that whatever the issues are there, they can be fixed priorly before releasing the final version, and this feedback will be iterated through several release before a final release. And when can I begin a designing? That is, here, when to start a designing, at what phase? The first phase is to collect a preliminary requirement and do the analysis of those requirements. And when can I begin a designing? This is an important question. That is, the life cycle model shows a design of the architecture, and this model begin with a preliminary requirement analysis, so that here we can clearly we cannot begin until we have an idea of our system requirements. Every architecture contains or it may be a collection of functional or a quality business requirement. Every architecture, it is a combination of what it must and should contain a functional and quality business requirements, and we can call these three requirements as architecture drivers. We can call these three requirements as architecture drivers. That is, what are those drivers? Functional requirement, quality requirement, and business requirement. Architectural drivers are mainly three, and are as below. Shown below. The first one is functional requirement, okay, and second one is quality requirement, and third one is business requirement. Third one is a business requirement, and these are called as architectural drivers. These are the three important drivers required to build a design a architecture. That is, in order to determine the architectural drivers, first we need to identify highest priority business goals. Then we turn these business goals into quality scenario or use cases. Before, in order to determine the architectural drivers, what is the first step is to identify highest priority business goals. There are many business goals will be there. Among those business goals, we need to identify a highest priority business goal, so that the unnecessary the priorityless goals can be initiated later. First thing is to attempt to identify highest priority business goals. Then we can turn these business goals into quality scenario, or we can may turn into a use cases. Next we will move to the next concept, that is ADD, attribute driven design. The meaning of this is this is a method for designing the architecture to satisfy both quality requirements and functional requirements, and is called as a attribute driven design. This ADD or attribute driven design is just a method for designing architecture to satisfy both quality requirements and functional requirements, because these quality as well as functional requirements are the that is initial drivers in order to design a uh, architecture. So ADD takes input as a quality attributes scenario and employs a knowledge about a relation between quality attribute achievement and architecture in order to design the architecture. What it does, it takes input as a quality attribute scenario and employ its knowledge about the relation between quality attribute achievement and architecture. Means that is in order to before while designing a architecture, we need to take care of a quality. We take a input as a quality attribute scenario, and this knowledge we implement while building a architecture design. And ADD, that is architecture driven design, is an approach to defining a software architecture. It is an approach for defining a software architecture, and this approach uses a recursive decomposition. It uses a recursive decomposition because here at each stage the customer feedback is important. Depending on the customer feedback, if everything is okay, the final version of the design has been released. If the customer is unsatisfied, it has some inputs to modify the design, then we need to go for a recursive decomposition process. And at each stage it applies tactics and different architectural patterns in order to satisfy a set of quality scenario. In the module 2 we studied different architectural pattern, the functional architecture, quality architectural patterns, security architectural patterns, usability architectural patterns. At each stage it may apply any of these architectural patterns and set a quality as a scenario. And in the textbook let us see the garage door opener example. Here we need to design a product, that is product. Here it is a software. That software should open a garage door automatically by implementing a sensor or any kind of technology. The garage door has to be open automatically. And how to design this architecture, that it has been discussed in this example, and that is the example name is called as a garage door opener example, because we are designing a product to open a garage door. And let us continue what are the specifications mentioned in this example. That is first thing is design a product line architecture for a garage door opener with a larger home information system. The opener is responsible for raising and lowering the door via switch, remote control or a home information system. It is also possible to diagnose the problems with the opener from within the home information system. Means we need to design an architecture in such a way that is door has to be opened either using a switch or a remote control or a home information system. And it is if any issues are present while opening the door of the garage, in that case the system should automatically diagnose detect the problems with the opener from within the home information system. And for this we add input to add. That is what is the meaning of add here? Architecture driver design input to add a set of requirements, functional requirements as use cases, constraints, quality requirements expressed as a system specific quality scenario. Okay. And scenario for garage door system. will be like this, that is